Okay, welcome to video 4, demo video 4 in this B05 Introduction to R coding. So remember, for this video 4, we've had the first 3 videos corresponded to lab 1, and now we're moving to lab 2 in the Omics Learning N drive folder. So if you go to lab 2, you'll be able to see the relevant files there. Note before we start that we have the Irish boys' names CSV file in our folder and the Irish girls' names CSV file in our folder as well. So these files are in our current folder where the corresponding ORMD file is, to make them more easy to access. That is the simplest way of organizing your files and your script as well. We'll look to changing directories during this brief demonstration, but just note that these files are there, and that's the easiest way to access them. If you're uncertain of where your files are, put them in the same folder as your script. So you can see here, what we're going to look at is a bunch of different boys' names over the time periods shown in the columns, going from 1964 up to 2016 or so. So you can see lots of numerical data as well as NAs indicating no data available or maybe a 0 value. So you can see it varies quite a bit, and we're going to look at that with R. So the easiest way to get started on this is to go straight to this ORMD file, and if you double click on it, it should open straight up like that. So you look at the same RStudio environment that you used to before. So this is our scripting area at the top left. Bottom left is the console where commands will be executed. Here we have the packages on the right-hand side, packages, files, plots, help, and so on. And then we have our environment here, which is empty until we declare variables, and they're in our history, which includes some older commands I had. So what we're going to look at this tutorial is importing data. So there's a few steps to think about here. So we want to import this dataset irishboysnames.csv file. And the easiest way to check where your working directory is, that's the key term, your working directory. And that's where we get the letters W and D from, WD. And hence the command get working directory, which I'm putting down below, has no arguments. So if you hit that, you'll see your current working directory, which should be the Omics Learning folder B05 for lab 2. Another way of doing this is to go to Session, Set Working Directory. Then you have a few options. You can go to Source File Location, which is the ORMD file where you are. You can go to Choose Directory as well. So for example, if I choose Directory, I'll be able to select a different directory. For example, I could select the intro material directory, and you could see that change down below. So now it says it's changed to that directory, set WD. And if I do get WD, it says that I've changed to that directory. If I wish to change back, a quick way of doing it is going to Session, Set Working Directory, and then go to Choose Source File Location, which sets us to the location where the script is, which is probably the easiest way to manage your data at least initially. So if you click on that, you'll see it goes back to lab 2. And I can check this with get WD. So see that it's lab 2. In addition to this, I can check the Files tab here on the right here. So you can see there, this is still set on the intro material. So this is not actually the right directory we want as such. So we can actually go back here, click on this, go to lab 2, and there we go. We have the CSV files and ORMD files visually apparent there. So there's more tricks as well. So if you have files here and you're struggling to read them in, if you click on Irish girls' names here, we can actually do a few things to it with the RStudio interface. If I can, so view the file, so you can view the file or import the dataset. So let's try view file first. So you can see there how the file is set up. It's CSV, so it's comma separated variables. You have the name, they're in quotes here, but that's not how it actually will look later. And you see Alaya, Aaron, Abigail, and so on. So that's why the data looks. And then if you go to Irish girl's name and then import dataset, so or will help you import a dataset if you're having problems importing it. What you see here looks very complicated, but it's just saying this is the file source. This is the data preview. So you have the names here, years as before, and then the values going along. Just go down, yeah, you can see some values. And then it says the names we want to call it. We could call it, IGN if we want. You can skip lines if there's a long header. You can set the default limiter to being a different type. So it could be white space, tab, semicolon. You can configure other features like NA. And then what's actually going here is this is actually the code that is executing. So it's using this library called reader, and it's using the function read_CSV, and the argument is the file name here, and that's assigning it to the variable IGN, and then we view IGN there. So it's several steps. So let's just hit import. It's going to automatically generating code for you in effect. Hit import. So you can see there, it launched the library reader. And this is our data. So we have that read in. There's lots and lots of entries all the way down to SOSIA. We can sort them like that if you want. It might take a moment because it's a lot of data. Yeah, so we can sort them back reverse. Susanna actually is maybe the last one. You can sort them by frequency per year if you want to. So you have Mary at the top there, whereas in 1988 it was Sarah. So that's one way. So now our data set is called IGN, and we have read it in using this alternate approach. So there's the structure of it. Where are we? So IGN is read in as it's not quite a table yet. Well, yeah, it's a data frame read in the language reader. What we can do, and this is smart practice. So if you use new commands they want to save, what you might just do is add them in here. So you might put a hash and just say, okay, use the library reader. So record that there. Use the library reader. I use this command, read_CSV with a CSV file. And then the final one was just to view it. So view IGN. So I'm just going to save those commands there in case I want to go back to them later. I don't need to put them in the script, but if I have them in comments somewhere, I can save them for later. I'm not going to add more space around this because I want to keep the same lines as you have in the original file. So an alternate way to do this is use the read.csv function in R as well, which doesn't require reading in a library. So we call that our new data set. Well, let's call it IBN for Irish boys' names. So you note that if we do read.csv and just do, in case I misspell it, we have to put file names in quotes, so recognize that it's just a text, piece of text. Do that. And then we go to view IBN. Let's see how it looks. What you see there is that actually has read in all right, but it may not recognize that it is supposed to be a table data frame. So we want to avoid that. So it doesn't recognize that as a data frame here, but sometimes that may cause an issue. So you see there, they got the name is the columns, and then we have the years as the integers. So let's just, for consistency, if you want to call something a data frame when it isn't read in as a data frame, just put the data frame command at the start and at the end. Like that. So inside this round brackets again. And yeah, we can see we've read in the name successfully. Yes, the years are X and then the year name. We can adjust for that. So you see there, we can actually substitute. Sub is a command to substitute. If we don't know what substitute is, just put a question mark. Oh dear, question mark. Oh, that's autocomplete for you. And you should see it appear in help, and that will explain more about it. And you can read more about it there, including sample commands there at the bottom. There's a lot of options for substitutions. And this is just a simple option where we say substitute X and replace it with nothing. So therefore we call it call names, IBN is our variable. And basically what we're doing is reassigning IBN here. And our input, the third argument here, is call names of IBN at the start. So reassigning it as a third argument. So this is the pattern to match, this is the replacement, and this is the new thing. So now let's view IBN. See, you've no X there, which is handy. So let's go on. There's different ways of looking at the data that you can draw yourselves. So dim is particularly a handy one because it gives you the dimensions. So you know it's over 2,000 columns and over 2,000 rows and 46 columns. Note that not all years are present. So what you can do then is answer these questions. What's the structure of the data? What do you notice here? That's really important. You read something in. Did you read it in correctly? And is it in a format that is useful for you? So one of the key things about reading in data is to learn about this key command subset. So if we want to take a subset of IBN, we can do that. And then we can use the special apostrophe on your top left below the escape key to select the years that we want. Maybe it's 2008. I'm going to get ones that are very high frequency in that year, maybe over 600. And that will give us back those names. So you can see there, this is not the most readable format. But you can see there we have Jack, Sean, Connor, Daniel, James, Adam. So what we can do is reassign this to a variable. So just at the start, type something in here, IBN 2008. And view it, IBN 2008. Oh dear. So that pops up. And there you go. So if we go to 2008, you can see that these were the most frequent names in that year. Yeah, the top, they're ordered there. So you had Jack, then Sean, then Connor. And then we can use the select command. So let's say we want to select select equals C. We've used the C command to denote that we're looking at giving it a set of columns we want to search for 2008, like that. That'll select that column only. So if you view it again, now we see that column only, but note also we lost the row information. So if we wanted the row names from IBN, we just select row names at the start, row names. I see the original one we had lost it. Whereas in the first one, so what we can do then is IBN 2008 and dollar and name. There we go. There's the names. Okay. And then we were writing data out. So maybe I want to write out IBN 2008, write .csv. So what I'm going to do next is type in the variable. So it's IBN 2008 is the thing I'm writing out. And then the file is the output file I want. So I might call it output 2008.csv. So note that the function here is write.csv. So that's it, writing out a CSV file. There are other functions that will do similar things. So hit return. And it's a good idea to just check which working directory you're in, because that's where the file will appear. If you're in the directory lab2, you should have permissions to write there, but I'm not 100%. So just check that. So you can see there we have output 2008. So if you go to the folder, we have output 2008 there, which we can view. So it's written now out as a CSV file. And just like other file formats, you can write things out in other file formats if you wish to do so as well. And you can see the frequencies over different years there with 2008 as the key column. So back to R. So write and dot, you can see there's an array of different functions to achieve that. Write.table, and you can add in different arguments. Say you want it in separated by white space or a colon or something exotic like that, you can do so as well. And there's lots of other functions in the likes of reader here. You see reader has lots of functions to let you write out different file formats. So if we want to read in more data, we can do that with the Irish girls' names as well, in the same way that we did for the Irish boys' names. It's literally the same procedure. So remember to keep your code when you write code to read in a CSV file, so you can recycle it to looking at other code. And that's kind of what we're illustrating here. So that concludes our brief introduction to reading data in and out.